Hello everyone, my name is Metehan Atay and I'm here to talking about our case study which called as forecasting monthly sales of vending machine. First, we need to take a look at our agenda. Our agenda consists these subgroups as problem and solution, executive summary, brief history, methodology, implementation, comparison of performance, and conclusion, of course. And the first one is problem and solution. Our first intention is finding the best method for demand forecasting to put into the practice and also get a solution for that, as artificial neural networks was the best method for demand forecasting. And another one is first of all we need to get an information about why is demand forecasting is so important. Just because of that, demand forecasting is very crucial for an organization in order to making right decisions. And in our case study, we choose autoregressive integrated moving average, seasonal autoregressive integrated moving average, artificial neural networks, and exponential smoothing with the single alpha methods. When literature was skimmed up, we can face a lot of studies which is done about another people in a very large range, which is changing from psychology to energy sector. Key challenge of this study is to choose most suitable forecasting method, also predict monthly demand of vending machine by comparing three different techniques. First method is simplest of the exponential smoothing method is naturally called simple exponential smoothing. This method is suitable for forecasting data with no trend or seasonal pattern. The formula is given as in the equation, where ft-1 refers to the forecast for previous period, at-1 is the actual demand for the period, and alpha is the weight. Alpha must be between 0 and 1. Second method is artificial neural networks, which we use. As you can see that natural neural cells is just imitated while using the artificial neural networks. And artificial neural networks, a kind of multi-layer neural networks, are illustrated in the signal flow from inputs x1 to xn is considered to be unidirectional, which are indicated by arrows as in the neuron's output signal flow as in the following figure. The last figure we use for forecasting is time series analysis, which is called as ARIMA-Box Jenkins model. And the Box-Jenkins model is a kind of theory that the most general class of models for forecasting a time series, which can be made to be stationary by differencing if necessary, of course, perhaps in conjunction with nonlinear transformations such as logging or deflating. After completing all the methods for forecasting, we need to evaluate our results according to their error rates. Just because of that, we just choose the mean average percent error was a good method for a study. According to our result, which we got from the three approaches we used, arranged and analyzed again by using mean average percentage error rates. But there was a kind of problem. Just because of that, we have some negative issues. And thus our solution was symmetrical mean average percentage error. By using this method, all problems was cut out. Symmetrical mean average percentage error is the forecast minus actual divided by the sum of forecast and actual as expressed in the following equation. In experimental study part, you are going to see a kind of things that which determines you a difference between mean average and percent error and symmetrical mean average percent error. As we can see that there is a huge error difference between these two methods. When these two methods are compared, as MAPE is error rate is lower and more appropriate, I mean symmetrical one. Due to this situation, S-MAPE, symmetric MAPE, was chosen comparison of performance, which we use to forecast for demands. Here you can see that best model table according to our study. And in conclusion, three methodologies, ARIMA, artificial neural networks, and simple exponential smoothing were deployed to forecast the vending machine products demanding Gaziantep University in Industrial Engineering Department based on the historical data from 2015 March to 2017 March. The results was forecasting for the last period showed that the artificial neural networks gives less symmetrical mean average percent error values from the another methodologies. For the ARIMA approach, the results indicate that the ARIMA model was best model to fit the historical data while the multi-layer perceptions. Although all these results based on the error measurement showed that the artificial neural network model was superior to other approaches, paired tests pointed out there was no significant difference among these errors. As a result, other factors should be utilized to determine the most appropriate model, but artificial neural networks is generally gives a better result than others for narrower sample sizes and less historical data and something like that. For that reason, artificial neural network should be chosen. Here are presentation. Thank you very much for your attention. Is there any kind of questions? Just ask me, please. Thank you very much again.